I am going to deal the topic of semiconductor memories. What is memory? Memory is nothing but a storage device. The data, instruction, address, etc. can be stored in it. Hence, the memory system contains many storage elements. Each will retain the information in the form of ones and zeros. Till recently, the memory used were of magnetic type. With the advances in semiconductor technology, now it has become possible to make the memories of various size and types. These memories became very popular because of their smaller in size, low cost and high reliability. The basic element of a memory is a flip-flop. Each flip-flop will retain one bit of information, either 0 or 1. So, to store 3 bits, we need 3 flip-flops. There are number of locations in a memory. Each location is meant for one digital word of information. The size of the memory is represented by m into n. M represents the number of locations in the memory and n represents the number of bits in each memory location. The commonly used m values are 64, 256, 512, etc. N values are 1, 4, 8. Types of memory. We can classify the memory according to the principle of operation, physical characteristics and fabrication technology. From the figure 1, we can classify the memory into 4 broad categories. First one is sequential access memory. The second one is read-only memory, simply we can call it as ROM. The third one is the random access memory, we can call it as RAM. The last one is the content addable memory, that is CAM. Among the 4 types, first we will see the first type of memory, sequential access memory. In the sequential access memory, the memory locations are accessed in a sequential manner, that is the reading operation and writing operation will be in the sequential manner. So, the time taken for each memory locations will be different in the case of the sequential access memory. For example, if you consider the 5th memory location, it will take some time. Suppose you want to read the 10th memory location, means you have to wait until the 6, 7, 8, 9 has to be paused. So, the time will be different for different memory locations. Again, the sequential accessed memory can be classified into 2 types. One is shift register and another one is charge coupled device. This shift register is of 2 types. One is static shift register and another one is dynamic shift register. In the static shift register, the content of the memory do not change with time as long as the power is on. Whereas in the case of dynamic shift register, the data is stored in the MOS capacitor. So, it will leak off after some time. So, it has to be refreshed at regular interval of time. The next one is the charge coupled device. It is implemented using MOS technology and it has a high package density and low cost. The next type is the read-only memory. The name itself has the meaning, we can only read from the memory, we cannot write into the memory. It is used to store the data which is fixed as a tables for various functions. Depending on the programming process, we can classify the read-only memory into 3 types. One is mask RAM, second one is programmable RAM, we can simply call it as PRAM. The third one is erasable programmable RAM, that is EPRAM. So, first one is the mask RAM. These are referred to as RAMs. In this type of memory, the data is stored during the manufacturing process itself. Once the data is stored, we cannot erase the data. The second one is the programmable read-only memory. These are referred to as PRAMs. In this type of memory, the data is stored after the final packaging. But in this case, it is electrically programmable and it is programmed by the PRAM programmer. The last one is the erasable programmable RAM. In this erasable programmable RAM, we can erase the data at any number of times and you can enter the new data. So, that is, it is reprogrammable. In the erasable programmable memory, the erasing may be done in 2 ways. One by causing the ultraviolet radiation, and another method is by applying proper polarity voltage. The next type is the random access memory. This is also called as an read-write memory. The main difference between the sequential accessed memory and the random access memory is, in the case of the sequential accessed memory, the data is, we are reading the data or writing the data in a sequential manner. So the time taken for each memory locations will be different in the case of sequential accessed memory. But in this case, we can randomly choose the data. So the time taken for each memory locations will be same in the case of random access memory. Again, this random access memory is divided into two groups. One is static RAM and another one is dynamic RAM. In the static RAM, the data is stored as long as the power is on. Whereas in the dynamic RAM, the data is stored in the MOS capacitor, so it will leak off after some time. It has to be refreshed at regular interval of time. The last one is the content addressable memory. It is the improved version of the random access memory. So in the case of random access memory, we can read and write. Whereas in the case of content addressable memory, matching also possible. That is, when you give any data, it will read, write, as well as it matches the input data with already stored data. So you can check whether the data is already stored or not. Matching also possible in the content addressable memory. Memories can be classified according to their physical characteristics. One is erasable or non-erasable. The second one is volatile or non-volatile. In the erasable memory, you can erase the data at any number of times and you can enter the new data. But in the case of non-erasable memory, once the data is entered, you cannot erase the data. That is, example is read-only memory. In the erasable memory, we can erase the data in two ways. One, by location, we can erase the data before storing the new information. For example, RAM cam. The second one, you can erase the data simultaneously by the exposure of ultraviolet radiation. Example, EPRAM. The next one is volatile and non-volatile. In the volatile memory, the content of the memory do not change as long as the power is on. That type is called volatile. Example, RAM. In the non-volatile memory, the data will be stored even if the power is switched off. Example, ROM, that is read-only memory. So we can classify the memory according to their fabrication technology also. So first one is unipolar technology, the next one is the bipolar technology. Static RAM and PRAM can be fabricated either by unipolar or bipolar technology, whereas dynamic RAM and EPRAM can be fabricated only by unipolar technology. Among the four types of memory, we will see the first one, that is the sequential access memory. In the sequential access memory, the memory locations are reading or writing in a sequential manner. Suppose if the nth location is under reading, if you want to read n plus kth location, we have to wait until the k locations has to be paused. The sequential access memory is of two types. One is first in, first out, and another one is first in, last out. First, we will see the sequential shift register memory, first in, first out. It consists of n shift register, each of k stages. Each register will have one of the n bits. B0, B1, Bn minus 1 are the outputs. The output is given as an input in the manner of a recirculating shift register. In the sequential accessed memory, we will see both the read and write operation. First, we will see the write operation. So during write operation, you have to make write enable is equal to high. When you make the write enable is equal to high, all the first AND gates are disabled because the bubble indicates the inverter. Because we are making write enable is equal to high, through the inverter it will become 0. So all the first AND gates are disabled. Only the second AND gate is enabling. So when you apply any data, it will enter into the register depending on the values. For example, now let us consider the data 001, 010, 011, 100. First, I am going to enter the data 001. While entering the data 001, the second gates are enabling. depending on the inputs. If the input is equal to 0, you will get the output of the AND gate is 0. If the input is 1, you will get the output of the AND gate is equal to 1, and which will occupy the register position in the first stage. That is, here we are taking the 3 bits and the number of stage will be 4. That is, k is equal to 4, n is equal to 3. So when you apply 0, 0, 1, which occupy the first register position. Again, when you apply the next data, that is 0, 1, 0, in synchronism with the clock pulse, the first data is shifted right and will make a room for the next data. Similarly, when you apply the next data, this data will be shifted right and new data will come into the first position. Similarly, all the data can be entered. While reading, we have to make the write enable is equal to low. So when you make the write enable is equal to low, because of the inverter, the first AND gate is enabling, the second gates are disabling. So while reading operation, the first data will come first. So this type of memory is called first in, first out. There is another type of shift register sequential memory called first in, last out. Here also we are using n shift register, each of k stages. Each register will hold one of the n bits. There is a difference between first in, first out and first in, last out. In the first in, last out, there is no circulation of data from the output to the input. The second one is, here the shift direction is also possible in the first in, last out. And one more thing is, the output and input is given from the same register stages. That is the main difference between first in, first out and first in, last out. Here also we are going to see both the read and write operation. First we will see the write operation. During write operation, we have to make write enable is equal to high and the shift direction is upward. Now let us consider the data 0, 0, 1 as it is in the previous case. That is 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. Here the number of bits will be 3 and the stage k will be 4. First we are going to enter the first data 0, 0, 1. Already we are making write enable is equal to 1. So that means depending on the write inputs, the AND gate will be enabled or disabled. If the write input is 1, the output of the AND gate will be 1. If the write input is 0, the output of the AND gate is 0, and which occupy the lowest portion of the register stage, that is the bottom of the register. Because we are simultaneously applying the shift direction upward, if we are entering the next data, automatically the first data will go up and make a room for the second data. Similarly, when you enter the third data, the second data will go up and the first data will occupy the second position and will make the room for the next data. Similarly, we can occupy all the datas. After that, after entering all the values, we will see the read operation, how we are going to read the data. So during the read operation, we have to make the write enable is equal to low. So when you make the write enable low, because one of the input is 0, so you cannot write any data into the register stage. That is, you cannot enter any write inputs. Only you can read the data. Simultaneously, you have to make the shift direction downward. While you make the shift direction downward, the last data will come first. Similarly, the first data will come last. So this type of memory is called first in, last out. Next we will see the read only memory. That is, in the read only memory, we can only read from the memory. We cannot write into the memory, which is used for storing the data permanently. It is used in combinational logic circuit, sequential logic circuit and microprocessor storage. Depending on the fabrication technology, we can construct RAM in two ways, one by bipolar technology and another one is the unipolar technology. They differ mainly in access time. The bipolar RAMs are faster as compared to the MOS RAMs, but the MOS RAMs occupies less area and consumes less power. So depending on the programming process, we can classify the RAM in three types. One is mask programmable read-only memory. The second one is programmable read-only memory. The last one is erasable programmable read-only memory. Among the three, we are going to discuss the first type, that is mask programmable read-only memory. These are referred to as ROMs. In this, the data is stored as the part of the manufacturing process itself. So now we are going to see the construction of RAM using diodes. So figure shows the construction of RAM using diodes. In this figure, each horizontal rows represents a register, and the input is given with the help of the switch select arrangements. Here, when the switch is moved to the position 0, the corresponding diode will conduct. So you will get the corresponding output. For example, when the switch is moved to the line 0, the corresponding diode will conduct. The output will be 1, 1, 1, 1. When the switch is moved to the position 3, the corresponding diode will conduct. The output will be 1, 1, 0, 0. Similarly, we can tell for all the lines. If the diode is present, the corresponding output will be 1. If the diode is not present, the corresponding output is 0. Instead of using the switch select arrangements, we can use the decoder arrangements also. Decoder is nothing but which will convert the active input signal into a corresponding coded output signal. Now let us see the figure. Here we are constructing the ROM using the decoder arrangements. In the decoder arrangements, we are replacing the switch select arrangements by decoder arrangements. Now let us consider the inputs A0, A1, A2. In this case, when you apply the inputs A0, A1, A2 equal to 0, 0, 0, and we are taking the input through the inverter. So through the inverter, it will become 1, 1, 1, 1. So when you apply the control lines, that is A2, A1, A0 equal to 0, 0, 0, only the first AND gate is enabling, because we are getting the 1, 1 through the inverter. All other AND gates are disabled. So you will get a high output in the corresponding line. The corresponding diode will conduct. So the output will be 1, 1, 1. So when you apply 0, 0, 1, because through the inverter we are taking the input for the second AND gate. So the input is equal to 1 in the first line. The second will be 1. The third we are directly connecting the A0 line. So that means the second gate alone is enabling. When you apply 0, 0, 1, you can check all other AND gates will be disabled. So the corresponding line will have high input. The corresponding diode will conduct. So you will get the output is equal to 1, 1, 1, 0. Similarly, you can connect the seventh one. When you connect the seventh one, that is all the input is equal to 1, 1, 1 means only the seventh AND gate alone is enabling. The corresponding diode will conduct. So the output of the value is 0, 1, 0, 0. So wherever the diode present, you will get the output is equal to 1. If the diode is not present, the output is 0. Instead of using the switch select arrangements, we are using the decoder arrangements, so which will give the corresponding high input to the corresponding diodes. We can construct the read-only memory using the transistor and MOSFET also. First we will see the read-only memory using transistor, that is BJT RAM. It is using bipolar junction transistor read-only memory. Before going to the BJT RAM, first we have to know what is transistor inverter. So with the concept of transistor inverter only, we are going to discuss the bipolar junction transistor read-only memory. The figure shows the transistor inverter circuit. The transistor used in this case is the NPN transistor. Here RL is the load resistance and RB is the base resistor. The base resistor is also called as an current limiting resistor because it limits the current to the input of the transistor. The input of the transistor we are giving is 0 volt or plus 5 volt. Let us consider when we apply plus 5 volt to the input of the transistor. Then the transistor will be in the on state, because the condition for the transistor to be operated is the emitter based junction is forward bias and the collector based junction is reversed bias. So when we apply plus 5 volt to the input of the transistor will be in the on state. So most of the voltage will drop across the load resistance RL. You will get very low voltage as an output. Similarly, when you apply 0 volt to the input of the transistor will be in the cutoff state. There won't be any potential drop across the load resistance RL. Hence the output will be high voltage. So when you apply plus 5 volt to the input of the transistor, the output is nearly equal to 0, that is logically equal to 0 volt. Similarly, when you apply 0 volt to the input of the transistor, the output is high, that is logically equal to 1. So in this manner, it acts like a transistor inverter. Inverter is nothing but a circuit which has only one input and one output. When the input is high, the output is low. Input is low and the output is high. So similarly, in the transistor inverter, when you apply high voltage to the input of the transistor, we are getting the 0 volt as an output. When you apply low voltage to the input of the transistor, we will get the high voltage in the output of the transistor. This is the transistor inverter circuit. So with the concept of the transistor inverter circuit, we are going to discuss the bipolar junction transistor read-only memory. The figure shows the BJT RAM. All the column lines are connected to plus VCC through the load resistance RL. The row line indicates the select line. In this case, the transistor used is the NPN transistor. All the emitter lines are grounded and the base is connected to the select line. Dotted portion indicates the transistor inverter. So you can compare the transistor inverter with the dotted portion. It resembles that of the transistor inverter. Suppose when you select the 0 line, so the corresponding line will be high. So because of the inversion, the output of the transistor will go low. When you select 0 line, so the forward stored will be 0, 1, 1, 1. So when the transistor is present, because of the inversion, you will get the output is 0. If the transistor is not present, you will get the same voltage as that of the input. Similarly, when you select the number 1 line, because of the inversion, you will get 0, 0 in the first two transistors. So the output word stored will be 0, 0, 1, 1. Similarly, when you select the number 2 line, the stored word will be 1, 1, 0, 1. So the select word and the stored word are shown in figure. Similarly, we can explain the construction of read-only memory using MOSFET. There are two types of MOSFET. One is enhancement type and another one is depletion type. Before going to the construction of MOS ROM, first we have to know what is MOS inverter. With the concept of MOS inverter only, we are going to discuss the MOS RAM. So the figure shows the MOS inverter circuit. In this case, we are using the MOSFET is N-channel enhancement MOSFET. The T1 is the driver MOSFET in the figure, T2 is the load MOSFET. So in this case, instead of using the resistor, we are using the MOSFET itself as a resistor. Because of the smaller in size, the MOSFET is 20 times smaller than that of the ordinary resistance. For that purpose, we are using the MOSFET itself as a load. And moreover, by deliberate design, the resistance of the upper MOSFET is 10 times greater than that of the lower MOSFET. So you compare with the transistor inverter with the MOS inverter. So instead of using the resistor, here we are using the MOSFET itself as a resistor. So in this case also, when you apply high voltage to the gate of the MOSFET will be in the on state. When you apply low voltage to the input of the gate of the MOSFET, the output will be 0. That is, when your input will be, the input of the driver transistor we are applying is 0 volt or plus 5 volt. When you apply plus 5 volt to the input of the MOSFET will be in the on state and most of the voltage will drop across the load MOSFET and you will get very low voltage as an output. Similarly, when you apply 0 volt to the gate of the MOSFET T1, it will be in the cutoff state. There won't be any potential drop across the load MOSFET T2, so the output will be high. So when you apply plus 5 volt to the input of the MOSFET, you will get 0 output, that is logically equal to 0. Similarly, when you apply 0 volt to the input of the MOSFET, the output is nearly equal to high voltage, that is logically equal to 1. So in this manner, this circuit acts as a MOS inverter circuit. So with the help of the MOS inverter, we are going to discuss the MOS RAM. The figure shows the MOS RAM. All the column lines are connected to plus VDD through the load MOSFET, and the row lines indicates the select line. So in this case also, you consider the dotted portion which resembles that of the MOS inverter circuit. For example, when you consider the 0 select line, so when you apply high voltage to the 0 line, the corresponding MOSFET will be in the on state. Because of the inversion, you will get the output is equal to 0. So when you consider the 0 line, the output word stored will be 0, 1, 1, 1. Similarly, when you select the number 1 line, the output word stored will be 0, 0, 1, 1. Similarly, when you select the number 2 line, the output word will be 1, 1, 0, 1. Similarly, we can connect all the lines, we can get the output. So far we have discussed what is memory. Memory is nothing but a storage device, and we have seen the classification and characteristics of memories. According to the classification, we can classify the memory into 4 types. First one is sequential access memory, the second one is read-only memory, and the third one is random access memory, and the last one is content addressable memory. This sequential access memory is further divided into 2 types. One is shift register and another one is charge coupled device. The second one is the read-only memory. Depending on the programming process, we classify the read-only memory into 3 types. One is MOSC RAM, second one is PRAM, and the third one is EPRAM. And the third one is the random access memory. This random access memory is divided into 2 types. One is static RAM and another one is dynamic RAM. Depending on the physical characteristics, we can classify the memory into 2 types. One is volatile or non-volatile, and another one is erasable or non-erasable. Depending on the fabrication technology, we can classify into 2 types. One is unipolar technology and another one is bipolar technology. Among the 4 groups, we have elaborately seen the sequential accessed memory. This sequential accessed memory is of 2 types. One is first in, first out, and another one is first in, last out. In the second type, that is read-only memory, we have seen elaborately that the MOSC RAM. In the MOSC RAM, we have constructed the read-only memory using diodes and transistor and MOSFETs.